last vocab term that we're going to focus on today is called a complete graph. And don't be confused on that one. It's not a connected graph. However, what a complete graph is it means that every vertex that you have is adjacent to all of the other vertices in that graph. Okay, so the way that we denote complete graphs is actually with a capital little letter K, and then we use a subscript, and that subscript tells us how many vertices there are. So for a K2 graph, that means that there are two vertices and they have to be adjacent, which means there's going to be an edge that connects the two. This is a K3 graph because we have three vertices and this vertex is connected to the other two. This is connected to the other two, and this vertex is connected to the other two. K4 graph, four vertices, and then it's connected to each of the three others, and a K5 graph, and so on. So as you can imagine, a K10 graph, while there are 10 vertices, that would not be very fun to draw because you're connecting each vertex to the 9 other vertices that you would have. So something of importance to note here would be, let's look at the degree of each of the vertices. In a K2 graph, the degree of this vertex would be 1 because there's one edge coming into it or going out, however you'd like to think of it. Same with this one, it's also 1. So both of the vertices in a K2 graph have a degree 1. In a K3 graph, we have two edges, two edges, two edges, two edges. Each of the vertices have degree 2. In a K4, each vertex has degree 3. In a K5, each vertex has degree 4. You've probably made the connection now that in a K10 graph, each vertex would have a degree of 9. For the last part of today's lesson, we're going to learn about circuits and paths, and specifically what are called Euler circuits and paths, as well as Hamiltonian, or sometimes just called Hamilton circuits and paths. Before we get into that, I have 7 different graphs here, and what I want you to do is I want you to try to figure out, is it possible? Okay, so each of these graphs is going to fit into one of these 3 categories. Can you retrace it and end where you started? Okay. So that's going to be one type of graph. If you start and end in the same place and you retrace it, which means you're not going to go over any edge more than once, okay, but you can get back to where you started. B is you can retrace it, but you don't end where you start. And C, it's impossible to retrace. Okay, so I would suggest that you pause the video and again, just use your finger and then try to play around with, if I start with this vertex right here, can I go to all the other ones, retrace it? And no, I can't. All right, so there I did the first one for you. This is a C. It's actually the same graph that we looked at before. So I would put that this one is C. Then try to do the same for the other 6 graphs. All right, so here we see, okay, here's what you should have come up with. For the second graph, I classified it as B because you could retrace it, but you couldn't end where you started. And then you can see what the rest were. So for example, here is the path that I took for B. Okay. This one I did A, which means that I could retrace it, and I ended where I started. Here's what that looked like. This graph was another C, which meant that I could not retrace it. This graph was a B, which means I could start in a spot, but I could not end in the same spot. This one you can't see very well, but there was actually an edge going here. Okay, so started here, ended here. This one was an A, which meant I could retrace it. And this one was a C, where I tried to retrace it and it just didn't work. All right, so in the next video, we're going to make some conclusions about these graphs.